Okay, I'm recording this. Most probably, I'm gonna keep this, put it in the YouTube, okay? So that those who have a problem.
So we don't have data.
No, you can watch it in the Saturday Sundays if you have a doubt. That can just do.
Sir, newcomer, sir.
Yeah, make it.
क्लास क्याप्टेन तमा हुनको या एसएमजी गर्न फिक्सर ड्र बिनिमा अनि हिन्दी छैन अनि ए आया ओइ बुम गेम न बोल बोल्दा बुफकी बास्केटबल म्याच अनि फिक्सर ड्र बिनि दिन तमा एसएमजी गर्न हुन तो लन्च टाइम you did not eat Kina. Thank you, sir.
Okay. Listen up now. So we will have a block period next Thursday. That block period we want to do practical test.
Or
This Friday, this Thursday, and today we are going to have test on after school. That is because you will be having your SCPW 345, right? So by 4 I will start. So before 4 you have to come here. I'll give the question paper in the class itself. Okay. So the class itself you are going to do the. So for now you don't do it. I'm not going to revise those things. Now you pay attention to what you will get to. So we have not finished the oscillation. There are some few topics. Maybe just cover the few topics and then we go further. Today we'll have start a new chapter also in the second period. So let's start with this topic, which is time period of pendulum.
this will not come in this.
This is not coming in the test. So let's understand what do you mean by time period of a pendulum. So, yes, there's a derivation for finding the time period of a pendulum, but we don't do the derivation. We just find the formula for time period, and with that formula, I'm going to explain how does this formula help us to find out the time period. Okay, is that clear? T equals to 2 pi. Do you know the time period formula?
Yeah.
L by G. This is the
2 pi by
time
G.
period of a pendulum. 2 pi L by G. What is L here? But okay, suppose I draw a pendulum here. This is your pendulum. So here, from where do you measure the length? From here to the bottom. From this is called the rigid support, right? This is the rigid support. So L is the length of the pendulum. You know, L is the length of the pendulum. Length of the pendulum. And what about G? What do you call G?
Gravity.
Force due to gravity. Acceleration due to gravity, not force. It is a acceleration due to gravity. What is the value of gravity? G value? 9.8.
9.8 meter per second.
9.8 meter per second. What does it mean?
acceleration
The
of
body on the
9.8
earth
meters
flows
per
at
second
this
is
speed
acting
for
on the body per
acceleration.
second, sir.
Yes. What it means?
In
Any freely falling body. This is a body which has a velocity 0 now. Okay. If I leave this body, then it starts falling.
Yes.
In the first second, the velocity of the body will become 9.8 meter per second. In the next second, it becomes double of that.
yes.
In the next second, it becomes triple of that. For example, if I take this approximately 10 meter per second square, okay, that means, this means your velocity changing 10 meter per second in a given second. Yes. Your velocity changing in 1 second by 10 meter per second.
Yes.
Yes.
That is the body.
So what does G means? Here the velocity is 0. Okay. In the first second, velocity becomes 10 meter per second. In the next second, it becomes 20 meter per second. In the next second, it becomes 30 meter per second. So in every second, velocity is increasing by 10 meter per second. So that Yes, why? So that our acceleration is g, which is constant. Is that clear? So this is what it means. It means that in a given second, our velocity is increased by 10 meter per second. Understood? So first 0, in 1 second 10 meter per second, in the next second 20 meter per second, in the next second 30 meter per second. So every time velocity is increasing by 10 meter per second. That's what is the acceleration due to gravity means. And therefore I told you, if I did I tell you this, if I give that example, if I let the two objects fall, no? Not in this class? Okay. So okay, then let me just give me your pen. Yeah, let's go. So if I make these two objects fall, which one will fall faster? What do you think? Pencil will fall faster?
Yes, you.
Because
Both of them will fall.
okay, I'll do it. Here, one example, I'll do it there. Okay. Both of them will fall?
Same.
At the same time? Okay, let's see. So I'll make them fall at the same time and from the same height. Okay. When I say 1, 2, 3, I'll just leave it. Is the height same?
Yes.
Almost same, right? Almost same.
1,
2,
2, 3.
Same at the same time? Those who did not see, just speak once, 4 times here. This is a book, okay? I try to make it from the same height.
Same.
Did you fall at the same time?
Yes, sir.
Doesn't matter if it is a top or if it is an iron ball. If it is an iron ball or if it is a rubber ball or plastic ball. If any two objects, you make it fall from the height of the building or from this height. If you make it fall from the same height and at the same time, both of the objects will fall at the same time on the ground. Doesn't matter what the size is or the shape is. Why? It's only because both of the falling object will have same acceleration, g. That means this will also in 1 second, now the velocity is 0 for both. In 1 second, this will also move with the 10 meter per second, this will also move with the 10 meter per second. And next second, 20 meter per second. Because every falling object will have same acceleration due to gravity value. Okay, that means the velocity is increasing by 10 meter per second approximately in a given second. So independent of shape and size, both of them
What's
will
the-
fall. Yes.
Will the feather and
Yes.
Coin.
The question comes. I'm coming to that. What if I have a feather and I have a pencil or a coin, whatever? Then do they fall at the same time?
No.
But if I have a vacuum, suppose I have a jar and I have a vacuum pump, I take the air out from the jar, I create an artificial vacuum. Now I make the feather or paper and pencil fall from the same height, then they will also fall at the same time. I said independent of size.
Yes.
Now why they are not falling now in the real case?
Because
Paper is
there is
falling.
drag force acting on it, sir.
Drag force by what? Drag force by
Air.
Yes, good. Drag force by air. That we call it friction force, right?
Yes.
Drag force, friction force. So just because friction force is acting more in the air, more in the paper, because of that paper is falling slowly. Okay. Otherwise, both of them should fall at the same time, and this happens. If you make them fall in the space, they will fall at the same time. The paper and the plastic, paper and the football, both of them will fall at the same time. So this is the G and this is L. I hope you understood this one, no?
Yes,
Now my
sir.
question was, this L, from where we measure this L? From top of this ball, or from center of the ball, or from down of the ball?
From center of the ball, sir.
This is very important. Whenever you find the effective, this length of the pendulum, you should always find it from the center of the gravity. This is called the center of gravity, CG. Okay. So CG is the, okay, what is CG? Do you know center of gravity?
Center of gravity,
The
sir.
class 10, right?
Where
Yes,
the
sir.
force act on, sir.
Okay, I'll just quickly explain the concept. Center of gravity means, okay, first of all, center of gravity is that point where we say whole weight of the body is active. That means suppose the weight of this ball is suppose 50 gram weight. There is how much? 50 gram weight. So this is the ball weight of 50 gram weight. Okay, 50. Now instead of considering this whole ball, I consider a point here. Because this point I am separately drawing here. This point is exactly in the center of this spherical body here. So if I consider this point also of 50 gram weight only, is it clear?
Yes, sir.
So what I'm saying, there is a spherical ball of weight 50 gram weight. Okay. Instead of considering this whole ball, I consider a point where in the center of this spherical body. At this point, I take it out for now. And this point is also having the same weight, 50 gram weight. Now, if I apply the force on this ball in this way, obviously ball will move in this way.
Yes, sir.
Similarly, if I apply a force on this bob, then bob will also move in this way. This point will also move in this way. Yes or no? Is it clear? So that means if I apply a force here, the bob will move up. If I apply a force here, the point will move up. Is it clear so far? So what we are doing is that instead of considering this whole body of mass weight 50 gram weight, I take one point of same weight, but this point will behave exactly as the whole body. That means this, instead of considering this whole body, I can consider this point and it will behave exactly as the whole body. How? If I apply the force on this body, the bob moves this way. Same thing, if I apply the force on this body point, the point will move this way. If I apply the force on the body upward, then the body will move upward. If I apply the force on this point, the point will also move upward. That means this point is exactly behaving like this whole body. Yes or no? Is it clear? If this point can be acting as this whole body,
Yes, sir.
because if I apply force this way, the point is also moving this way. If I apply the force this way, the body is also moving this way. Why we are doing this? The question is, why we are considering? Yeah, what happened? What happened in there? Stop talking there and just
I
listen.
don't understand.
So you ask now, relax to me. Listen and ask. I don't think that's it. You're talking something else there. Look at here. If you don't understand, just try to look at here and try to get it. What I'm saying is this. Concept of center of gravity, which is there in class 10. What is the concept? Why do you take this point? That's the main point. I'm standing here, let's take my example. My weight is 50 gram weight, suppose, or 60 gram weight. My weight is 60 gram weight. So, okay. Now, center of gravity concept says, don't take the whole body. You take a point. You take a point whose weight has to be similar to the whole body. So, my weight is 60 gram weight. I take a point whose weight is also 60 gram weight only. Okay. Now, if I move this way, that point should also move that way.
Yes, sir.
If I move this way, that point also should move that way. Okay, that means instead of taking my whole body, if I replace my whole body with the point, just point only, okay, point of same weight as my body, that is 60 gram weight. That means this point will behave exactly like whole my body.
Yes, sir.
If my body is moving this way, then point will also move this way. Okay. Now if I apply, suppose for example, if I apply 10 Newton force on this body in this way, and I move by 2 meter, then for this point also, if I apply 10 Newton force, then this point also has to move by 2 meter. Then only we can say this whole point is behaving exactly like this whole body. Can I say that?
Yes, sir.
Now the thing is, this point cannot be anywhere in my body.
Yes.
The position of that point has to be very special. Then only this point will act as
Sit.
same as my body. Let me give you the example of a scale. Do you have a scale?
Yes, sir.
If I give you the example of scale, then it will be nice. This is scale, okay? Is the scale rectangular shape?
Yes, yes,
So where do you think the position of center of gravity, if you know, just tell me. It should be the geometric center of this scale.
Yes, sir.
For any regular shape, the center of gravity has to be the geometric center.
Yes, sir.
Yes.
So it should be geometric center. Okay, why it has to be the geometric center? That's what I'm explaining. Suppose this scale is over here, okay? And this scale is of weight of 50 grams, suppose. Mass is of 50 gram or 5 gram. So mass is 5 gram. Okay, which is over here. Now I have a point whose mass is also 5 gram. This is an imaginary point. But this point has to be in the geometric center. Okay. Now if I apply a force on the scale over here, suppose I apply the force 5 Newton over here on the scale, on this point. Then the scale will rotate like this,
Yes, sir.
or it will go like this.
No.
It will rotate like this, right?
Yes, sir.
Okay, good. If I apply this force over here, 5 Newton, how does the scale behave? It will rotate like this.
Yes, sir.
But only if I apply the force on the geometric center, 5 Newton, then only the scale will move like this.
Yes, sir.
So if I apply 5 Newton, suppose the scale moves like this by 2 centimeter. Okay.
Yes, sir.
Now, if I consider this point and if I apply a force 5 Newton, how much this would move then? If it is the same weight, 2 centimeter. Only if so 2 centimeter. This much is clear so far.
Yes, sir.
If I apply 5 Newton in the center of the scale, then it will move by 2 centimeter, and the scale weight was 5 gram. Okay, scale weight was 5 gram. Same thing if I have a point whose weight is also 5 gram, then if I apply 5 Newton on the point, then also it should move by 2 centimeter. Yes or no?
Yes, sir.
But the question is come, why did I choose the center point? Why did I choose? Because anywhere I could have chosen the center of gravity, right?
Yes.
Anywhere I could have chosen the center of gravity. But why did you choose the center point? It's because of one reason. Only if we choose the point in the center of the scale, then only the point will behave exactly like a scale. Otherwise, if I would have choose this point as the center of gravity, suppose this point was my center of gravity, then if I apply 5 Newton force, then this point will only move by 2 centimeter, right? But the scale is rotating. Then are they behaving same?
No, sir.
If I apply 5 Newton over here on this point, then the scale will rotate. But if I apply 5 Newton force on the point, then the scale will displace by point will move by 2 centimeter. Then are they behaving same?
No, sir.
So this point cannot be any other point. This point has to be that special point, so that if I apply the force over here, then the scale also moves by 2 centimeter, and that point also will move by 2 centimeter. But if I choose this point as the center of gravity, then if I apply 5 Newton force, then the scale will rotate. Okay?
Yes, sir.
And if I choose this as my center of gravity point, then if I apply the 5 Newton force, then this point will move 2 centimeter. Are they behaving same?
No.
No. That is the main concept that many of you misinterpret. Many of the students misinterpret. That's what I wanted to do, all these things. So center of gravity is not at any point where the weight is same. Okay. We say center of gravity is that point where the weight is same as the whole body. But it doesn't have to be that much one. It has to be that point where the weight has to be same of the body. For example, weight of the scale has to be same of the weight of the point. Plus, that point should also behave in the same way as the scale behaves. Okay, therefore, this point has to be the special point. Therefore, in the spherical shape, center of gravity has to be the geometric center. If I choose any other point, and then if I apply the force, then that point will not behave same as the whole body. Is that clear?
Yes, sir.
Understood? No. Only if I choose this point as the center of gravity, if I apply 5 Newton, then this will move by 2 centimeter. And if I choose the point, if I apply 5 Newton, then it will move by 2 centimeter. But if I choose this point as the center of gravity, if I apply the force, the scale will rotate. Okay. And if I choose a point, and if I apply the force, then point will just move. Then both of them are not behaving same way. It is a little, that is the concept you have to understand. Okay. Now center of gravity in the every kind of regular shape. If you take a square, center of gravity has to be geometric center. If you take a cube, where is the center of gravity? Cube. Geometric center. Yes or no? Cube, you understand no cube?
Yes, sir.
Yeah, yes, sir.
Cube.
Center.
Yeah, cube. If we take a circle, what is the center of gravity of the circle?
Circle.
Geometric center. Yes?
Yes, sir.
So if I have a regular shape of the object, center of gravity would be the geometric center. But if you have an irregular shape of the object, where is the center of gravity then?
They have all must act together.
So you have to find the balancing point. You have to find balancing point. That will be. Suppose this is the pen, right? Where is the center of gravity of this pen? So looking at this pen, do you think the center of gravity will lie in the center? Do you think it should lie in the center?
No, sir.
Do you think there is more mass towards this side, right?
Yes,
sir.
So center of gravity will shift towards more mass.
Yes.
Because center of gravity also means average weight. It means what? Average weight of the body. So if this pen was uniformly distributed, then I could have said center of gravity is exactly center. For example, here in the scale, this mass and this mass everywhere it is uniformly distributed, and this is completely rectangular shape. Yes, God is lucky why you're laughing too much. Be serious and answer, okay? Don't laugh too much. Yes. So here should be exactly in the center. This is your balancing point, and this should be your center of gravity,
Yes, sir.
which comes exactly in the center around. This is your 15 centimeters, so I'm balancing exactly 7.5.
Yes,
Okay, so this is how you can find out the center of gravity also. Same thing here. This is irregular shaped object. Now how to find the center of gravity? I'm sure it won't be in the center, and I see there is more mass this side. So center of gravity should be towards this side. Okay, let me check. I try to put in the center. Okay, it's rotating this way, right?
Yes.
That means there is more mass here. So I shift this way. Now this is the balancing point. So exactly on top of this, on the middle of this balancing point, there will be the center of gravity. So for any irregular shape object, you just have to balance them, and in the center of that point, you get the center of gravity. For regular shape object, it's just the geometric center. Is it clear?
Yes,
Yes,
So I don't want to discuss too much about the center of gravity. Fine. Okay, this is the concept. Now, so again, the reason we choose this point as a center of gravity, because just now I told you, right? Because center of gravity has to be that point. If I replace this whole body by that point, then this point should exactly behave in the same way as this whole body. This is what is concept.
Yes, sir.
If I have this whole body, spherical body, if I replace this whole spherical body by just this one point, then this point should behave exactly like this whole body. So I cannot take the length from top. I cannot take the length from bottom. Okay? Because this is not the center of gravity point, this is not the center of gravity point. So I have to take the length from rigid support to the center of gravity. This will give me the exact length of the bob. Is it clear?
Yes.
Sir.
Every time, whenever we find the length of the pendulum, we always find it from the center of gravity. Because center of gravity is the point which is the average position of this whole body. Okay, average position of the whole this body weight is this point, center of gravity point. So we have to find from the average position. Okay, we can find from here, we cannot find from here. Same thing if you want to find the distance between Earth and Sun. Okay, this is your Earth and this is the Sun. You don't find the distance from here to here. Okay, you don't find the distance from here to here. You have to find the average position, right?
Yes.
Average position of Sun is center, average position of Earth is center. Therefore, it has to be from here to here. Is that clear?
Yes, sir.
Good. So, because why I'm talking too much about this is because questions will come from this concept. Because this length is very important. This length is very important for you to understand. So measure the length from the center of gravity. So looking at this expression, you tell me, time period depends upon what factor?
Center of gravity.
No, so don't, where is center of gravity? Center of gravity constant I use just to find the length.
Acceleration to
Then
gravity.
it's
From
depend on
this
length of
formula,
the
it depends upon what?
Length of
length
Length of the pendulum and
acceleration to gravity.
how is the length of the pendulum? If I increase the length of the pendulum, what happens to the time period?
Directly proportional.
Increase or decrease?
Increase.
Okay, so time period is directly proportional to
Length.
length of the pendulum. So that means time period increases. Okay, if L increases, then time period increases. Next, time period is inversely proportional to if G increases, then what happens to time period?
decreases.
So these are the two factors on which time period depends. Now G is, we say it's 9.8 meter per second square. Is it a constant value or it can change also?
You can change.
Change in different
Is the
places.
G value same at the equator and the pole?
No.
Or different? Where it is maximum?
At the poles.
Towards the pole.
Towards the pole G value is more,
More.
and towards the equator G value is less.
Yes.
So for the same pendulum, if I have same pendulum, if I find the time period in the equator and if I find the time period in the pole, do I get the same answer?
No.
I don't get the same answer. Why? Because G value is different.
Yes, sir.
In which case do we get the more time period? Okay, you tell me. Okay, you tell me. In which case, in the equator or on the pole, in which case we get the more time period?
Equator.
Equator? Why equator we get more time period? Why do we get more time period in the equator? Look at the board and tell me. Time period depends upon what factors? You tell me just now. What are the factors on which time period depends? No talking on that. I'll let you out. It depends on the value of G only. You one more stand up. Time period depends upon what factors? Value of oscillation. Yes. Acceleration due to gravity and what? Only acceleration due to gravity? Length of? Okay, you tell me from this expression, how does the length change the time period? If the length increases, what happens to the time period? Let me see. Time period increases. If G decreases, what happens to the time period? Time period increases. So you tell me G value is more in the equator or less in the equator? It's less in the equator and more in the pole, of course, right? So if G value is more in the pole, you tell me in which, in the pole or in the equator, where the time period will be more? In which case the time period will be more? In the equator or in the pole?
More than
Equator, time period will be more. Why? Because the value of g, not gravity, acceleration due to gravity, is less. Did you understand? So tell me why g value? Why? Look, in the mountain, as you go towards the mountain, what happens to the value of g? Do you know? Do you know what happens to the value of g? It is same or it will be different? It will be different. So it will be less or more? More. So let's leave it. As g value, again we need to have to see all the cases for g value. So when we are on the surface, g value is 9.8 meter per second square. That is maximum. As you go towards the altitude, okay, as you go towards the altitude, g value decreases. As you go inside the depth also, g value decreases. G value is maximum on the surface. Remember that one. As you go from the surface towards up towards the altitude, g value will decrease. As you go towards the depth of the earth, also g value will decrease. So if g value will decrease, time period will also change, right? Time period will increase. So question will be asked like that. You have a pendulum. You measure the time period of the pendulum, and suppose you now go to mountain and you measure the time period. Will the time period change or not? Time period you have to say it will change. Why it will change? Because the g decreases as you go towards the mountain. If the g decreases, the time period will increase. Understood?
Bhutan will have low G value.
Suppose they ask the question from Chelula to half. You are in the Chelula, you are doing the experiment. You find the time period. Now you came back to half. Now g value, time period should increase or decrease then? You came back from Chelula to half. Huh? Time period will decrease or increase?
Time period will increase.
You are in the Chelula. There is a g value in the Chelula and there is a g value in the half. Where is the g value more? Because Chelula is up. I said as you go towards the altitude, g value decreases. So they might give you this question, okay? So if you know there may be some places, some places. So yeah, g value decreases. No, if you compare with the pole and the equator, then g value is more in the pole and the equator is less. If you compare with the altitude, then also g value changes. G value decreases with the altitude and decreases with the depth also. If you go towards the center of the earth, suppose you measure the time period here on the surface of the earth. Now you go to some mines. Mines means obviously inside the earth, right?
Yes.
Coal mines. You went inside the coal mines. Now you measure the time. Suppose they ask the same question. Suppose you have a pendulum clock. Okay, and you measure the time on the surface of the clock, and now you went inside the mine, and they ask you what happens to the time period now. What happens to the time only? Because pendulum clock, it measures the time.
Yes, sir.
One oscillation means 1 second. If you consider one oscillation means 1 second, so they might ask you in terms of time also. You measure the time. You have a pendulum clock. Suppose you measure the time on the surface of the earth. Now you went inside the mine. Okay. Now you did some work. Now the question is, the time that is measured in the mine will be. It will slow down or it will increase. That's the question. Time will slow down or time will become fast? Because one oscillation means time will 1 second. In the time will increase or decrease. Slow down. Time will slow down or time will become faster. That's my question.
Time will become faster first. When the G value decreases, time become faster.
Time period will become faster. That means time will become faster or time will slow down. Time period faster means for one oscillation means 1 second now. So one oscillation means 1 second.
Yes.
Now it will take more time for one oscillation. So time will become slow down or time will become faster.
Yes. Because it's slow down. Slow down.
Time period will increase.
Yes.
But time period increase means time should slow down, right?
Yes.
Because one oscillation means 1 second. Now time period will increase. That means time period now suppose become 2. That means for one oscillation now you are taking 2 seconds.
Yes.
So question will be asked like this. Again you have to use the brain. Okay. When you increase the time period, obviously time will slow down. Because one time period means 1 second. Now for one oscillation, if you are taking 2 seconds, then obviously time will slow down.
Yes.
Okay, I'll make you write because you forget things. You first write this one. Yeah. Copy this one. Draw this diagram. Now see. And I've seen some of the copies, some of you have not completed your work. So I said to you that I'm going to give you internal marks. I'll mark it down. Next time if I collect the copies and if I see the same situation, you're going to get very less marks. I told you to do the work, I gave you everything. Still, you're not completing the work. And the diagrams are wrong, so many diagrams, you're in class 12 now. I draw the diagram in the class, that velocity versus time graph, x versus t graphs. Looking at the graph also your copy is wrong. And one more thing. Whenever I did maths, some of the questions I leave it half. For example, x equal to t by 2 and t I finished. I told you to do 3t by 4 and t suppose. That also you have not completed. In 12a I've seen most of this problem, not in 12b. 12b, I've checked only few copies yet. But that means you're not completing your work.
No, because that is
Some of you, not everyone, some of you are not completing your work. So when are you revising? If you're not completing the work, that means you're not obviously revising. First you should complete, then you should revise. Because I don't get time to check homework every day. It doesn't mean you don't complete.
shut down the camera discussion.
What is this? Okay, this example. No need to try this example. This. What is it?
Now we have to draw that.
I draw that pendulum.
Not pendulum.
Which one? Huh?
This one, 60 gram weight also.
Which one? No, that's just for explaining. Why did I click the duster?
Just here, sir.
Duster X limits.
This duster, no, every class it is coming out.
So you also have duster, right?
Yeah, I also have a duster.
This duster is Chinese part.
Done? Okay, right. No, equator. Hi. This is done, right?
No, sir.
This is not done? And one more. Any doubts so far? This is understood? Did you understand the last line? When the time period increases, clock slows down. Did you understand that one?
Yes, sir.
Because suppose on the surface, one oscillation means 1 second. Okay. Now on inside, if you go towards the mine or when you go towards the mountain, now your time period is not set. Okay. For before one oscillation, it was 1 second. Now one oscillation is taking suppose 2 seconds because time period increases, right? So now oscillation is taking 2 seconds. And obviously the 2 seconds can be considered as 1 second there. Yes or no? Because one oscillation means one time.
Yes, sir.
Therefore the clock slows down. Okay, this kind of question might come in exam. So far we discussed everything related to G. But we also know time period depends upon the length also. So let me ask this question. You are swinging on a swing and you are sitting on the swing. If you stand up on the same swing, will the time period change or not?
Yes, sir.
On the swinging swing, sir.
It's swinging on a swing while sitting. Now you stood up in the same swing. So do you think the time period changed?
Yes, sir.
Is the length changing there?
Yes, sir.
Yes, sir. As the center of gravity changes, the length will also.
Yes. When you are sitting, obviously center of gravity will be lower, right?
Yes, sir.
Now, if I sit, my center of gravity position will be lower. If I stand, my center of gravity is here now. If I sit, it will be lower. So, in the same swing, if you stand and swing, the center of gravity position will be higher. Let me draw it. This is your swing, okay? Same length swing. This is swing. And suppose you're sitting in the first case. I'm just drawing the rough diagram sitting. The center of gravity will be almost here. Yes or no?
Yes, sir.
So this would be your effective length. Effective length would be from the center of gravity. Is it clear?
Yes, sir.
Now the same length swing. I try to draw exactly the same way.
Just the length also.
Now you're standing. So obviously standing means this will be your position now.
Yes, sir.
Right? Just drop. So your center of gravity will rise up, right?
Yes.
Now this will be your effective length. Okay. So therefore you have to understand what this L is. In both the cases we are talking about the same swing. So normally what you assume length means this length you assume. The length of the swing. But it's not that. Length you have to measure from the center of gravity. So same swing. Now length is decreased, right?
Yes, sir.
So what do you think? Time period will increase or decrease now? So length decrease means now when you stood up, length decrease. So time period will also decrease. Because time period is proportional to L. So that you might have seen that one. If you swing and try to oscillate, you oscillate little slower. If you stand and try to oscillate, you oscillate faster. Have you seen that? If you stand and try to swing, you oscillate faster because time period is decreasing. Time period decrease means you are oscillating faster. Okay, you can do that experiment whenever you next time you play in the swing. Okay, so write about this. You can draw this diagram also to explain. Yes?
I don't know, sir.
Is there any doubt so far? This one understood? Omo?
Yes, sir.
Good. What about you? What's your name? Yours.
Kamal.
I forgot your name. What is your name? Say it. Come on, say it. What is your name? You don't understand. Yours. Oh, sorry, you can see, no? Because I'm asking you, what's your name? Karma, no? What about you? You didn't see when I asked. You didn't see
She was
when I asked.
confused.
Chensu, no name, Chensu, right? fine. You can write this diagram and this is your CG. This is your CG. Okay. So whenever L decreases, your time period will decrease. Let's start. You better draw this diagram just for rough diagram. And if you draw the diagram and explain in the exam also, that's good. Because there we can show the position of center of gravity right. Okay. Done. Suppose one more person sits here. One person is sitting and one more person sits on top of the person. Will the time period change or not?
Yes, yes, sir.
Why?
Because
That's the height difference.
See, the person also sits. So center of gravity will change a little bit. Okay, if you change a little bit, the person is also sitting. Both the persons are sitting only. The position of center of gravity changes a little bit. But here we have to use one more concept there.
okay, it depends on the weight of the two persons.
No, does it? That's what I'm saying. Time period, does the time period depends upon the mass and weight?
No.
Yes, sir.
Okay, let me ask this question. This is a pendulum, okay? It is oscillating, it will have some time period. Time period formula, you know, is 2 pi L by Z. If this bob, this is called bob, right?
Yes, sir.
If I replace this bob or mass, suppose this was wooden block before, it was wooden. Okay, now I make it iron one. I change the bob, make it iron one, same size bob. Will the time period change or not? That's good. Understood? Same size bob, which is made of wood before, now I replace it by iron. So will the time period change?
Yes.
Time period will not change because time period anyway. Did you see it in the time period formula? Mass term?
No.
It only depends upon the length and g.
Yes, sir.
So here, even if I change this mass with the I change with the
Metal box.
metal, then also the length is same, right? Doesn't matter. So mass, even if we have a wooden block or we have a iron block, we have plastic block, whatever, doesn't matter. As long as the length and g is same, time period will not change. Sometimes they ask this question: we have ice, and we measure the time period of the ice, and suppose ice is melting after as the time proceeds. So will the time period change when the ice melts? It won't change because ice is melting. Our length is same. Okay, it doesn't matter. Pendulum will oscillate with the same time period. Okay? So that's one more concept that happens. Same concept we're going to use to explain. Some one person is sitting, another person is also sitting on top of the person. In that case, we adjust, though the center of gravity position changes actually, but it changes a little bit. But answer would be time period will change, answer will change. Why not? It will not change because we have just double the mass, right? We have increased the mass, and changing the mass should not change the time period. That's the reason we say even if the two persons are sitting on the chair, time period will not change because it is independent of mass. Okay, is that clear?
Yes, sir.
Yes, good. So those answers I've written in the. I'll give you on Saturdays, okay, that you copy it.
Yes, sir.
Okay. Because I'll give you all the. I think one or two you got the examples. So yeah, this part is over. Now we go to another part of. What is the time period of a oscillating mass spring system then? If you have a spring mass system,
The time period
spring mass system.
still no.
Okay. Before I go to this, there is a concept called ideal pendulum. Do you know what is ideal pendulum?
When the pendulum doesn't move, sir. This call it
When the pendulum doesn't move.
Yes, sir.
There's a definition in the book, ideal pendulum. In which definition? Huh? What is it? Now that the question comes, what do you mean by ideal pendulum? Ideal pendulum is that pendulum which has a very heavy suspended mass. It has a heavy suspended mass. The mass has to be heavy, and this length of the string is called the string has to be. String is flexible. It has to be what? Flexible. It has to be flexible. It has to be perfectly elastic. You know what elastic means?
Yes, sir. Stretchable, sir.
Stretchable. If I stretch it, then again it comes back to the same position, right? That's what elastic. Perfectly elastic. Sometimes they ask you this in MCQ. What do you understand by ideal simple pendulum? The ideal simple pendulum are those pendulum which have very heavy mass, and the string has to be flexible, perfectly elastic, and it has to be one more extendable. What?
Inextendable.
Huh?
Inextendable.
Extendable, inextendable.
Extensible. Inextensible. And
Extendable.
Extend.
Inextensible means the length should not change. The length of the pendulum should not change. So this fact, if this is true, then we have an ideal pendulum. But obviously we don't have the ideal pendulum. But we have a pendulum close to ideal pendulum.
there is
Because
business also.
ideal pendulum cannot be, to make perfectly elastic is impossible. Okay. Any material cannot be the perfectly elastic material. Okay. So, but this is the ideal pendulum, whose the string has to be flexible, inextensible, length should not change, and it has to be perfectly elastic. Perfectly elastic means even if the length changes, it should come back to the normal configuration, normal position.
Yes, sir.
And the mass which is connected over here should have very heavy mass. It should be what? Heavy mass. If this is so, then this is called ideal. Is it clear? You can copy this one. How much you got? How much you got?
30.
Only 13,000, sir.
30,000. Good. Because there were no parents, so all the streets only bought. If the parents had come, maybe you would earn more. 13,000 will be enough for your.
Sir, if we put our stall in front of this Kasu school, then 40,000 will make 1 day.
If the parents come, all the students.
Suspended.
Done this, done.
No, sir. Alikatila.
This what is it? What should the time period in the spring mass system? This is just spring mass system. It can be vertical also. Like we can do the experiment with the vertical. It can be like so. This is spring of spring constant K. So how to, again here we write the direct formula for time period, okay, and we see time period depends upon what in the spring mass system. Is it clear?
Yes, sir.
Okay, last one to speak straight. What are you doing? So time period is nothing but 2 pi over omega. Yes?
Yeah.
You know omega over here, right? Do you know what was omega?
Yeah.
Yes, sir.
What was omega? Omega
Y
was
by G.
No. Divide by K.
Yeah.
In terms of K and mass, do you know what is omega?
K by M.
Omega square equals to K by M, I think. This one
Yes,
is
sir.
remember.
Omega is equal to square root of K.
Yeah, omega is equals to square root of K by
Sir, did you drink?
is square root of K by M. Fine. So is it okay? This one? Last year we derived this one. Not derived, we have already got this one. So 2 pi, so by omega, right? So omega is K by M. So if you have by omega, can I write M by
M by
K?
K. Yes.
It will just be inverse, right?
Yes, sir.
By omega. So omega, if I want to inverse it, then this will become M by K.
Yes.
Do you understand? Or?
Yes, sir.
Good. So this is the formula for tan period.
But now, mass
Now which time period, sir? Spring mass system
Spring
time
mass
period.
system, yes. So it depends upon what? Spring mass system here depends upon mass
mass equals
and spring constant.
Spring constant.
And sometimes they might ask you this
This
question.
year all the formulas will cook our brains, sir.
It's not that difficult. The time period is directly proportional to mass of the spring. Yes, mass of the load, not spring, mass of the load. And it's the mass of load. And time period is inversely proportional to spring constant. Sometimes the question might come from here. They will give you two spring constant. One value will be more. Which will have more time period? That kind of question. So here time period, mass increases, time period increases. Here K increases, time period decreases. Using this concept, you can answer all the concepts of question, okay? But you should know this formula. Question will be asked from this concept. Question will be asked. Yes, what is it? Okay, write one question if you finish.
Yes, sir.
I'll give you later on. I'll give the question in a Saturday, Sunday note. Saturday, Sunday, I'm not giving the notes actually. I'm giving you some questions with the solution. Okay?
Yes.
I'm giving you notes every day because you every day go and revise. Therefore, I'm giving notes here. If I give you in the last day on Saturday, then obviously you want to study. But Saturday, Sunday, I'll give you some of the questions from the past year's paper and questions from the instruction guide with the solution. So that you can check with the solution also. Sometimes maybe one or two unsolved ones. Yep. Next position.
Next one is here.
Yeah, one more. There's one more topic left and we do one. Bell rang already, right?
1 minute what? Sir,
जुन फिजिक्स खाइराखेको छ
Okay. So particle is suppose moving in this way, and this is a question of particle. Please suppose. So is this so? If the particle is moving with a uniform speed, what motion is it called?
uniform circular motion.
Do you say uniform circular motion?
Yes.
If the particle is moving in a uniform speed in the circular part, we call it uniform circular motion. Yes?
Yes, sir.
So, this is the particle P suppose. Yes? Now this particle has a position vector. Suppose this is a position vector of particle P. Okay? This is how we show the position now.
Yes.
So this is the origin. Look at here. Look at here first. This is the particle P, which is undergoing circular motion, and this is the position of the particle. I show with the arrow from the origin. Yes. Now we want to prove that circular motion is similar to the simple harmonic motion. Okay, how? Let me show you. How is the circular motion similar to the simple harmonic motion? Can it be similar? If you say, I told you, first day only I told you there is a difference between uniform circular motion and simple harmonic motion, right? But here we can show also. So, this is a particle which is undergoing circular motion. And this is the position of the particle at any time. Suppose here the particle is at this position. Now if I draw the projection of this particle, what do you mean by projection? Projection means a perpendicular line. A perpendicular line. So I draw a projection of this particle, that means a perpendicular line over here. And let's say this is another particle, P prime. This is another particle, P prime. Okay. Did you get it here? Look at here. This is the actual particle which is moving in the circular path. I draw the projection of this particle over here. So this is my new particle, P dash. Okay. So what is the position of this particle from the origin? Again, this is the position of the new particle. Yes or no?
Yes, sir.
When the particle P is over here, suppose, then my position vector of this particle P will be this one.
Yes.
So if I draw the projection of this particle P, then this will be the position of. If I draw the projection of this particle P, then I get this point. Again, this will be my new position vector. Yes or no? That means, as the particle position is changing here, suppose when the particle is P is here, then P prime will be here. When the P is here, P prime will be here. Can you see it?
Yes, sir.
So, as the P is changing, our P dash is also changing.
Yes, sir.
Suppose now P is over here. Now what is the position vector? This one is the position vector. So what would be my projection of this? Projection of this would be this one. So this would be my P dash, yes or no?
Yes, sir.
And this would be my new position vector of P dash.
Yes, sir.
You see, when the particle is moving in this way, our position vector is decreasing this way, right? Decreasing. When the particle is moving this way, our position vector is increasing, right?
Yes, sir.
So here can we say that here it is going left and right? Can you
Yes,
see
sir.
this way?
Yes, sir.
When the particle is moving from here to here, the position vector is increasing this way, right?
Yes, sir.
When the particle is moving from here to here, this position vector is increasing like this. Yes or no?
Yes, sir.
So can I say this here it is going left and right, but here it is going in the circular path?
Yes,
Yes,
sir.
sir.
So what it means? It means that whenever the particle moves in the circular path, its projection will move in the simple harmonic motion. Can I say?
Yes, sir.
Whenever the particle moves in the circular path, its projection, what will move in the simple harmonic motion?
Is
Projection.
particles.
Projection will move in the simple harmonic motion. Same thing here also. Suppose the particle is over here, this is a new position, and your projection will be here, right?
Yes, sir.
Whenever the particle is moving in the circular path, its projection will move in the simple harmonic motion. Is it clear?
Yes, sir.
So this is for understanding. We are not going to do any maths, but this nicely tells us one very important fact. What is the important fact? This question might come in the MCQs or fill in the blanks. So fill in the blanks, you have to know this statement. What is the statement?
Is also
Uniform.
circular motion.
Yeah. What were you saying? Say it. Complete it. Uniform circular motion is.
Similar to SMH.
Not similar. Okay, I'll write it in a better way. Yeah, I'll write this way.
Sir, we should draw that.
If you want to draw, it's fine. Otherwise, the drawing is there in the book also. When a particle moves in a circular path, it is under uniform circular motion. Use shape. It is under uniform circular motion.
Little particles move.
Uniform circular motion. Oh God, did you finish this one? When a particle moves?
Yes, sir.
Uniform speed.
Yeah.
Particle moves in a uniform speed on a circular path. So, okay, look at this. Here the projection is done on the diameter, right? So we have to say projection is done on the diameter. So this is what is the statement. Simple harmonic motion is nothing but the projection of uniform circular motion on a diameter of the circle. So they will give you this question immediately in the filling the blank. Where any one of the blank thing would be blank. Most probably this one or any one.
Diameter.
Is this understood?
Yes, sir.
Very simple. So whenever the particle moves in the circular path, its projection will undergo simple harmonic motion. Simple. Okay. There was one question that I want. We have not solved any questions with the kinetic energy, right?
Yes, sir.
So kinetic energy, potential energy, or energy question. I'm going to solve one question related to that.
Total energy.
This one. This question. Okay, go to page number 54. Page number 54 in the book. Maybe it is not. Copy. Page number 54. Did you see the question practice problems in the page number 54? In this book, this is the problem I'm talking about. Page number 54. They are given book. Not done. Why? What were you doing? This last one also not done. Are you finished already, right?
I finished, but here.
Please write faster, okay? Otherwise, it will be late. So let's read this question. Did you get the question? Where is the book? You have not opened the book. Why? Did you open the book? Did you see the question?
Yes, sir.
Last, did you see the question? Everyone, one more. Did you see the question? Yes. Page number 54, question number 1. See. Okay. Yes, from there. Mambo, you read the question.
With the displacement of the city is 1/2 the amplitude A, what fraction of total energy is A kinetic energy and B potential
Wait.
energy?
Okay, people answer. So did you all see the question?
Yes, sir.
When a displacement in simple harmonic motion is 1/2 of the amplitude, What fraction of total energy is kinetic energy and potential energy? Yes. Okay. So, Garen, you tell me, what is the formula for potential energy? What is the formula? You know it. What is the formula for potential energy? Half kx square. What is x there? X is? What is k? What constant? Spin constant. Please stand up. What is the formula for kinetic energy? Can you tell? Half? General formula for kinetic energy. General formula. Yes, you also stand up. Next. What's the formula for kinetic energy? General formula, not with the complicated formula. Don't know. Kinetic energy formula. Who can?
Half mv square.
Half mv square is the general formula for kinetic energy. Half kh square is the general formula for potential energy. Can you tell what is the total energy formula? Half k a square. So all these three formula you know? Yes. You're going to simply use this formula to answer this question. Is it not? If I do, if you get very less in test, I'll give you 23 times. Keep in mind. I don't know whether you will do it all night. I'm going to see it next day. Okay. So, what is the question here? Question is, when is the displacement in the simple Harmonic motion is 1/2 of the amplitude? Okay. What is displacement given here? 1/2 of the amplitude. So question is, and the question they have given. Again, read the question. It's very important to read the question. Nicely understand the question. When the displacement in the simple harmonic motion is 1/2 of the amplitude. Okay. First thing is given x, which is displacement, is nothing but a by 2. Good. What fraction of the total energy is kinetic energy? First question. What fraction of the total energy is kinetic energy? So question is like this: fraction of total energy is kinetic energy. What fraction? So obviously this means we have to find total energy, ratio of the kinetic energy by total energy. This is what this means. Yes or no? Fraction of total energy is kinetic energy means we have to find the kinetic energy with respect to total energy. This is what we have to find out. Is that clear?
Yes, sir.
Okay. What fraction of the total energy is kinetic energy? So total energy in the denominator, kinetic energy in the numerator. That's the question. Okay. So let's solve question number A then. But question number A, if I try to solve, then kinetic energy formula is half mv square. But no mass is given, nor velocity is given. And anything else is not given. So I cannot use this formula directly?
Yes.
Okay. So we go to question number B first, second. If the question number B is not given, then there is a way. So question number B is what fraction of total energy is potential energy, right?
Yes.
So that's the question. So again, this means what? This means potential energy divided by total energy. Can I solve this? Now I think I can solve this one with this concept. Total energy, what is the formula for total energy? What is the formula for potential energy? Half k. But in this case, what is x? A by 2. So I just put a by 2 whole square. I put half k a square. So this half k and this half k cancels out.
Yes.
This will give me a square by 4. 4, right?
Yes, sir.
Divided by a square. Can I cancel this a square and this a square also?
Yes, sir.
Or you have a habit of writing this way. A square by 4 and this 1 by a square. This a square will be on down, right?
Yes, sir.
This all you can write also, you can cancel here also, it's up to you. So 1 by 4. So this is our answer? Yes?
Yes.
This is our answer of the second question. What fraction of the total energy is potential energy? So we write potential energy divided by minus total energy equals to
1 by
1 by 4. Okay. If in the same question if they ask you what percentage of total energy is the potential energy, then you just have to multiply with the 100. If they ask you percentage. But the method is same. Is it clear?
Yes, sir.
If they ask you fraction, keep it as fraction. If they ask you percentage, just multiply this with the 100, you get the answer. Okay?
Yes, sir.
Suppose they have the percentage of the total energy, percentage of potential energy by total energy in this question only. Then you just have to do 1/4. Sometimes they ask percentage also into 100. This will give you 25, right?
Yes,
Yes, sir.
So the answer will be 25%. In case they ask you percentage, then you can do the same with this. Now come back to this first question then. Okay, I don't know the kinetic energy and my formula is half mv square. It's not given. But how would I find the kinetic energy then? Can you tell me? Yeah. Total energy minus?
Potential energy.
Yes. So I can do that way also. I don't know the formula of kinetic energy, but I know potential energy formula. We know this concept, right? We know this concept. Total energy has to be equal to potential energy plus kinetic energy. So in this case, can you write kinetic energy is nothing but total energy minus potential energy? Is it okay? Anyone having any problem? Just raise your hand right now. Is any doubt? Yes? Who is it? Yeah, any doubt? Yes? This, can I write this one or not?
Yes.
Yes. So what is total energy formula? Half K A square. Half K A by 2 whole square, right? Potential energy is half K A by 2 whole square because X is A by 2. Is it clear?
yes, sir.
This is nothing but half K A square.
Yes.
Good? Okay, you first copy because I have to erase that one. You can copy this one. You can keep this space here, okay? First question, keep this space here.
Suppose copy.
You can copy B first also, it's up to you. Copy B first. B is solved already. B is solved or not? You tell me. Yeah. Whatever you are asking me now. This is the percentage of B. Are you dreaming or not? Yes. B is already. Did you get this one?
Yes.
Yes, you? No, who will tell? If I ask, then only you tell. Or your newlywed wife, you don't speak because of shy? Only the one who is newlywed, new family, different side. Why are you doing shy? Which part you didn't understand? Which part? Do you know the formula of total energy? Huh? Do you know the formula of total energy? So, have you done it in the class or not? Not done in the class? You are absent or what? Were you absent when you did total energy? Huh? He was absent. Huh? So, what is the formula for total energy? Do you know total energy is equal to potential energy plus kinetic energy? Yes or no? Do you understand English? Potential energy plus kinetic. Do you know that one? Do you know first one? Total energy plus X equals to A by 2. Do you understand? What is in the question? So why is not X? But I explained there, no? In the question they had given X equals to A by 2. I asked you, then I wrote on the board. I did not write it. I asked everyone, they said you should give by 2, then I. So what were you doing when I did that? Because there's a problem in English, you don't understand English. So, you understand English? Don't say leave it. Because you don't know why X equal to A by 2 is coming, that means you're not hearing. That means you're not paying attention. X equal to A by 2 is given in the question. So just after finishing, you don't say, so I didn't understand. You take the responsibility. Did you hear the question from the beginning or not? You don't know what question is. You don't know what is total energy equals to. So that means I have to first teach you ABCD. Then again, ABCD means this kinetic energy, everything. Then only or you take the responsibility, you say, okay, so this part. Do you understand potential energy equal to half K square? Understand? Do you understand the total energy equals to half K square? Total energy equals to half K square. Do you know that? You don't know? Why don't you? Did we do in the class? This is you are seeing for the first time. Total energy equals to half K square. Are you seeing for the first time? What what's the difficulty here? You know potential is this one, kinetic is this one. You know how to cut half up, KK? So what is the problem here? That's what I... Pay attention from the beginning. Don't give up responsibility. You have to be responsible. I told you test, and all these things should be known to you if you are prepared for the test. So last time I remember in class 11 you got very less, fail. Don't do all this in 12. In the test you fail again. Don't commit the same kind of problem. Take responsibility. There can be a situation you don't understand, you tell me where you don't understand. This part. You don't know the question itself. Then how would you understand? Okay, this is done, last part. Because we don't have time for it. I'm taking it very slow. All these questions are there. I was supposed to leave it for you to solve. Because I've already given the concept. Because now this is the end of the March, and only we have not even finished one unit, oscillation. You see how vast is the units? But still I'm taking it slow because it is the beginning. You take a little pace to move down. Because in the coming days you won't be that slow. I won't be able to give you all the notes. Considering the practicals, 10 practicals, 2 days will be gone for the practicals, 2 periods. So you'll be only getting 3 periods per day. But still it's getting slow now, we are slowing down. Because I know some of you have you take time to solve it, therefore I'm taking time. In future I won't be taking this much long. Because this is the first chapter, because if I just finish one chapter in 1 month, the whole month we have started from the month of March, I'm not taking any classes like that, I'm teaching every classes constantly, still we are not being able to finish. And how many chapters you see? There are how many chapters are there? And this is one of the shortest chapters actually. We should not take this much time. If you see the magnetism, electricity, it's very long chapter.
Yes,
Optics, very, very long. Okay. Please do a little bit from your side. Otherwise you just lag out. Okay. And you repeat the same story. So what to do now? If I teach you everything like this, again I'm teaching it because I know some of you have still problem here. Therefore I have to teach everything. Otherwise I could have left. You know this is nothing but a square by 4, right?
Yes, sir.
By half k square. How to solve it? Now what to do? What do you think should I do?
K square is K square.
I can first take this as common. I can cut here and here. Can I? No. So don't cut here and here. You have to take the common. You cannot cut because there is a minus sign here. So you cannot cut here and here. So half k square, half k square. This looks common. So I take it out. So here we get 1. Is it fine? Minus half k square is gone. We have 1 by 4. 1 by 4 divided by half k a square. This will cancel now. So we just have 1 by this one, 1 minus 1 by 4. Is it fine?
Yes, sir.
Good. So we have a 1 minus 1 by 4. So what is the answer of this?
3 by 4.
4 1s are 4 minus 1, 3. So it is 3 by 4. 4 1s are 4 minus 1, 3 by 4. So this is the answer. Yeah? It's fine. Half k square was common, so I have to take it out first. So here we get only 1. Here we get 1 by 4 because this is 1.
Yes.
So this is how we get it. Okay. We cannot cut it directly there.
1 by
What's the last part of the question?
4.
I what displacement? This is the initial system. Let's do the last part of the question. Maybe I won't be able to start the new chapter today. Let's start. next question. Can you read the next question? Okay, tell me what is asked in the next question. At what displacement, in terms of amplitude, the energy of the system, half kinetic energy and half potential energy. Okay, there are many ways to do it. Okay, many 3-4 ways. I'll teach you one way. If you solve in other ways also, if you can solve in other ways, that's well and good also. You get the full marks. I'll teach you one general way, very simple way. There are many ways. All the ways are simple only. Okay. Potential energy is nothing but half k square. This is the formula for potential energy. Oh, what is the question? Did you understand the question? Question is, at what displacement? So, x is our question mark. What should be our displacement? When,
As a mean for the
in terms of amplitude, we have to find the x in terms of amplitude. When the energy becomes half kinetic energy and half potential energy. So our energy is half kinetic energy and half potential energy. What should be the value of x? That's the question. Okay.
Yes, sir.
So it cannot be 0. 0 means what? Potential energy is 0. Potential energy has to become half. So there are many ways to do it. I'll start with this way. So potential energy is half k square, right?
yes, sir.
Okay. Which way should I do it?
X equals to
Okay, I'll do it.
a square divided by
I will do it with the general case, okay? Because the question here they accept half kinetic energy, half potential energy. In the question, if they change 1 by 3 kinetic energy and 2 by 3 potential energy, then you should be able to do it also, right?
Yes, sir.
So therefore, I'm going to do it for with the general case, okay? But in this case, I could have done by 2 ways also, maybe 3 ways also.
No.
Wait. Now listen. Kinetic energy should be what?
amplitude times
Half
amplitude
V. M V square. But do you know what is V? V is nothing but omega
rest.
A square minus B square. Do you know this one?
Yes, sir.
Yes, sir.
So I'm going to write M as M. V square means omega is square.
Omega is square.
Omega is square. A square minus. Is it fine?
Yes,
This kind of- this is general case. Now question they are saying, according to the question, our potential energy has to be half and kinetic energy has to be what?
Half.
Half. Is it fine?
Yes.
This is according to the question, right? Is it fine?
Yes.
So when the potential energy is half and kinetic energy is half, so obviously they have to be equal, right?
Yes.
Half kinetic energy, half potential energy, that means obviously they have to be equal. Yes or no?
Yes.
Because the total energy is nothing but potential plus kinetic energy. Suppose total energy is 10 joule and potential energy is 5 joule, the kinetic energy has to be 5 joule. Yes or no?
Equal.
It has to be equal. So half cancels out.
Yes, sir.
So potential energy half cancels out.
Yes.
Yeah?
Yes.
Is there any confusion? Half potential energy because they have said in the question, therefore I am writing half potential energy, half kinetic energy. Fine. Half cancels out. Potential energy is half kx square.
Equals to
Okay, let me just finish here only. Yeah, what is m omega square do you think?
K.
K. So it is nothing but half k a square minus x square. That is the kinetic energy. Kinetic energy would be half k a square minus x square. Simple so far.
Yes.
Potential energy is half k h square. Kinetic energy is half mv square. M is m. V square is nothing but this. And I got m omega square is nothing but k. So I can write kinetic energy is this. Now look at this. How to solve this one? You have to find x, right? You have to find x. Half k can I cancel it out?
Yes, sir.
Yes?
Yes, sir.
You know how to solve this equation? Yeah.
Yes.
So it is x square equals to a square minus x square. So this x will come this side, it will become positive x.
Yes, sir.
A square. What will be this?
2x.
2x square? Fine. It will be 2x square. 2x square equals to a square. So what is x square then? A square by 2. What is x then? Plus minus a root over 2. Is it fine?
Yes, sir.
X would be square root of a square by 2. So x would be square root means plus minus, right?
Yes, sir.
Plus minus a square, 2 to cancel out, we get a. Only we have to do the square root over 2. Is it fine?
Yes, sir.
So this is our answer. X has to be plus minus of a by root 2. Then our calculated potential energy becomes half.
So what did you do?
Today for the surface tension new chapter, I wanted to show you one experiment. Let's take a look.